Let f of xy equals z be a differentiable function. In this exercise, we will show that the gradient of f is orthogonal to the contour lines or level curves of f. Because the domain of f is on the xy plane, the gradient of f will be made up of two components, the partial derivative of f with respect to x and the partial derivative of f with respect to y. We obtain level curves for f by setting z to be equal to some constant. Hence, the equation of a level curve is f of xy equals a constant, which we call k. Suppose that the graph of f is the surface shown on the right. Geometrically, f of xy equals k on the surface means that we take the horizontal plane z equals k and intersect it with the surface. And so we have our first level curve. We generate different level curves of f in this fashion. We take horizontal planes at different constant values of z and intersect them with the graph of f. When we talk about the orthogonality between the gradient of f and the level curves of f, we mean the orthogonality between the gradient of f and the projections of the level curves on the xy plane. To get the projections of these level curves on the xy plane, we translate these level curves vertically to the xy plane and get the image of each curve on the xy plane. And so we end up with a contour plot of f. Contour lines are often used on flat maps to represent different altitudes. It is to these contour lines that we will show that the gradient of f is orthogonal. We start by parametrizing the different contour lines. Suppose that the parameterization for the contour line at z equals k is given by the vector function r of t, where x equals x of t and y equals y of t. Then the tangent vector is r prime of t, whose components are x prime of t and y prime of t. Since this parametrization is along the contour line z equals k, plugging these into the function, we have f of x of t, y of t equals k. Now, it is a simple matter of taking the total derivative of z with respect to t using the chain rule. This derivative is given by the partial derivative of f with respect to x times the derivative of x with respect to t plus the partial derivative of f with respect to y times the derivative of y with respect to t. This should equal the derivative of the constant k. And of course, the derivative of a constant is 0, so that the total derivative of z with respect to t is equal to 0. One can easily check that this quantity is equal to the dot product between the following vectors. The first vector has components the partial derivative of f with respect to x and the partial derivative of f with respect to y. The second vector has components x prime of t, y prime of t. Observe that this first vector is the gradient of f. The second vector is the tangent vector, r prime of t. Therefore, the dot product between the gradient of f and r prime of t is 0. Since the dot product between the gradient of f and the tangent vector is equal to 0, the gradient of f must be orthogonal to the tangent vector. Therefore, the gradient of f must be orthogonal to the contour line.